Hello, I'm Stefan Kreber, I'm the project leader for LXD, and today I'd like to go over a topic that keeps popping up on our forum, and for which there's no single good answer really. So I'm going to be showing you a number of different solutions, and you can pick whichever works best for your specific environment. So the topic at hand is ingress. Effectively, how do you expose a service running inside of a LXD container or LXD VM to the outside world? To do this, what I've got here is a Raspberry Pi that's deployed with LXD 5.0 and is currently running a single instance on top of a normal LXD BR0 type bridge, as we can see here. So that's the physical NIC, and this particular system comes with a bridge that includes that physical NIC already, which lets us really kind of show all the different options available as far as exposing a service to the outside world. So now say in that loader terminal, I get a shell inside the instance and I run a service on port 1234. Oops. I'm gonna manage to get it right at some point, maybe. Okay, it doesn't like dash v for some reason. Okay, so all right. So I've got netcat listening on port 1234, and currently the instance is running on that IP address on the LXD bridge. So I can connect now from the client. This will work just fine. I'm connecting from the Raspberry Pi to the service running inside an instance on that same Raspberry Pi. That works fine. That's not very useful in many cases, because unless the Raspberry Pi happens to be your main system that you're accessing stuff from, that won't do you much good. But that's what works out of the box. Okay, can cancel that. I need to start the netcat again. For good measure, I'm just gonna put it in a loop so we don't need to keep restarting it. Okay. So now if I try from my own machine, so here, and I want to, well, let's do the netcat, I just want to access that address. Well, that's not gonna work, obviously. That subnet does not exist on my machine. It is nowhere near accessible from here. So I just can't get it. The first option that you can do is if you control your router, so if you can go, and how to exactly do it there depends completely on the vendor. If you can go in your router and you can add a route for this subnet here, so the LXDBR0 subnet, to route through the machine that is hosting those LXD containers, then things will pretty much just work. So I can try doing that first. So I need this subnet to route through this address. Let's go on my router. My router is a Linux system, so in my case it looks like this. So you do root add the subnet for the LXD bridge running on the Raspberry Pi via the IP address of the Raspberry Pi itself. You put that in place, and now if I try again from my desktop machine here, now it works. And what happens here is simply that my machine goes to that IP address through its default gateway, which is my router. The router has a route for it through the Raspberry Pi, sends the traffic to the Raspberry Pi. Raspberry Pi has a route to the bridge that it's running, and you can connect to the service. That's nice and easy. It works fine. Will work whether you're using that on wired network, Wi-Fi, whatever. It will always work. It is a very convenient solution, but it does require you having the ability to add new route entries into your router. If it's running Linux, then it's as simple as what I just showed. Keep in mind this is not persistent, so you need to make sure it reapplies on reboot. But if you're using a normal consumer grade type WRT type based router or something like that, you can usually go in the web UI of your router and then add some static entries in there. That should work just fine and will handle such cases. You should make sure that the address of the machine that's hosting your containers is pretty static, either like a static DHCP list or something like that, so that the route doesn't end up breaking. You don't have to keep adding it with the right address. So that's option number one. If that's possible, that tends to be really the easiest. Option number two would be using Macvlan. That's pretty easy to do with LXD, but that has some downsides. So in this case, what I'll do is that I'm going to actually be stopping the instance and I'm gonna be replacing its default ETH0 coming from the default profile with a different one. So it's still a NIC, but NIC type is Macvlan. Parent is that very long name here. And the name inside the instance is ETH0. Okay. Now if we start it back, it fails. I forgot to test that. That could actually just be an issue with the... So that's actually one of the problems with using Macvlan, is that its support is not quite universal. Some network cards don't support it. In this case, I'm gonna see if I can just cheat and set the parent as the bridge that I happen to have, but I don't think that's gonna work. Let's see. Okay, it did start. The question is, does it actually get an address? It did. Okay, so that works. Normally, you will use Macvlan against a physical NIC, which is what I did initially. But the NIC driver needs support for that. Apparently, there's some issue with the Raspberry Pi 1 in this case. Because my machine uses a bridge on top of that NIC, I just set the parents to that instead in the Macvlan device config, and that worked. But there's gonna be some weirdness, I'm pretty sure. So if we look at the config right now, we can see if 0 is Macvlan, parent is currently BR0, and that works. Doing that means that the container has changed IP address now for one that's on the same subnet and same network as the Raspberry Pi. That should mean it's now reachable from the outside, and it is. So I can now, oops, I need to actually start that loop again. Okay, I can actually connect just fine from my desktop computer here. That works fine. There is, however, a pretty significant downside to using Macvlan. As convenient as it is, it breaks this. So you can't connect from the host to a guest that uses Macvlan. So if that's important to you, if you need to connect from the host to your container, don't use Macvlan, it's just not gonna work for you. Now, an alternative to Macvlan in such cases would be to use a bridge. As we've already seen, I do have a bridge in place, but that's not the default on Linux systems, and how to configure that depends on your Linux distribution. So it's another case where there's no single easy answer. In the case of Ubuntu, this system uses Netplan, and we can see here that it comes with a BR0 bridge that actually has all of the network config applied to it, and then bridges the physical NIC into it. And the physical NIC itself down here doesn't have much in the way of config at all. So the result is effectively this, which is BR0 here, physical NIC here, which has BR0 set at its master. And if we look at the IP addresses, we only have IP addresses on BR0 and on LXD BR0. There's nothing on the physical NIC itself. If you get such a setup working for you, then that makes your life quite a bit easier with LXD, because you can again stop the instance. It's already stopped. Okay, let's just go and edit its config directly. And here, instead of using Macvlan, you can just say it's bridged. The parent BR0 is the bridge. It's all good. Save it. Start it back up. And we'll see it behaving pretty much identically to Macvlan, but with one pretty significant change in behavior. So it's running, start the loop. Did it change address? It did. So 203 now. Okay, so it's connected from my desktop just fine. But now let's try from here. And now it works. So a bridge works both externally and internally. So you can actually connect from the host to the guest just fine if you've got a bridge in place. As I said, the downsides to a bridge compared to Macvlan is that you need to potentially reconfigure your entire system's networking to be applied to a bridge rather than your normal physical NIC. And that can be quite annoying to do, especially because it's very distro dependent. So that's for your normal options as far as just getting traffic from the outside into like directly routed or directly routed to the instance. Now, none of that would work if you're dealing with a cloud instance, for example, or an environment like that where you can't just route across the internet, or where you might not have multiple addresses or a subnet or something that you can put your instances on. In such cases, you're gonna go back to the initial behavior, which I'm gonna fix. I'm gonna make happen now. So I'm just gonna remove the DH0 override, start it back up. So it's gonna move the instance back onto LXDBR0. There we go. I'm gonna go onto my router and I'm gonna delete the route that I added. Okay. And I'm just gonna make sure that I can't reach that network at all from my machine. Okay. And then let's go into the instance, start netcat again. Just make sure it works fine by connecting from the host system to the guest. It's fine. Now, how do we expose that? So say the only IP address that you have is the address of the host system. So in this case of the Raspberry Pi, that would be your only publicly reachable IP address. So now let's say we want that particular instance to be reachable. Like if you reach this IP address on say port 1234, it reaches the instance on port 1234. The first option is effectively to do NAT. And you could do that manually directly with IP tables and make it such that reaching 1234 on that IP address here gets forwarded to the internal address of the instance. Or you can have LXD do it for you. I know my preference, but in this case, what we should start doing is stop the instance and place a device override on U1. And we're going to be setting a static address through the HCP to make NAT easier. So let's say we give it 200, then start U1, and it should be taking that IP address. There we go. Now the next step, so I'm going to put the netcat thing in place again. What we want to get is that I should be able to connect from my computer to this IP address on 1234, and it should connect to the instance. Currently it doesn't, but let's make it work that way. So we're going to be adding a new device to the instance. Let's call it 3W. The type is proxy, and then we need to set up what address to listen on, which in this case is going to be TCP, the IP address is 172.17.30.49, port is 1234, and we want that to connect to the IP address inside. I don't remember if that works with NAT, but I guess we'll find out soon enough. And there's an option to just do plain NAT. Okay, and this works. So now LXD has effectively put a NAT rule in place on the host that just forwards straight to the instance, and that works perfectly fine. There is one option, so that uses NAT. The downsides to using this approach is you need to have the static address. It also relies on the fact that the host, in this case the Raspberry Pi, is effectively the router for all traffic coming back from the instance. This happens to be true in this case. This may not be true if you're just putting instances on some random VLANs or something like that and you want to bind the host address, but the host address is not the router. Effectively, you need the traffic to be properly symmetric for this to work. But there is another alternative that Proxy can work without using the NAT mode. And in that case, it becomes quite a bit more flexible, actually. So let's remove the override again. So we don't even need the static entry at all. So that's on U1, let's leave 0. Okay, now restart it again. See what IP address we get this time. Yeah, I was kind of afraid of that. The NS mask is being nice and giving us back the same IP address. It's not really a big deal. Actually, let's just reset things. So I'm just gonna delete the instance, launch the instance again, because it didn't have anything useful, so it's fine. And once it's back up, that should give us a completely random address. Okay, start the while loop again here. And let's look at what we have. Okay, completely different IP address. Now let's add the proxy again, but this time without the NAT mode. And this again just works. I can actually write something and mix it through. What's going on now is that LXD actually spawned a tiny process called fork proxy here, which takes care of listening on the host system and on the IP address that was configured, and then forwards that traffic into the container across the namespace boundary effectively. This is super flexible because you can actually proxy across protocol. You could proxy over to a Unix socket, for example, instead of a TCP socket. Actually, why don't I show you that? So if I remove that, and instead of connecting here onto the default address inside the container, let's say we want Unix and then tmp foo.sock. Okay, so now new connections would connect and then try to establish connection to this. It currently does not exist, so the proxy would probably fall apart pretty quick. Yep. But say we change this one now to listen on tmp foo.sock and now connect from here. Now it works. So now you've got a client connecting over TCP, but then the proxy converts that over to Unix socket. This makes it pretty fun because while you could actually do this, oops, ETH0 now. Okay. So what I did now is I completely masked the IP, the ETH0 network device, so it doesn't exist anymore. That container no longer has any networking whatsoever, but you can still connect from the outside and send it stuff using that proxy device forwarding to a Unix socket. So this can be quite an interesting feature from a security point of view, because it lets you isolate things far more than you would normally expect. So that's another pretty cool mode. The issue when you do things that way is because fork proxy handles the connection and connects back into the container, you have no idea inside the container who you're talking to. All connections will look like they're just coming from the host system. That's it. You're not gonna have any, like the source IP information is gone at that point. There is a workaround for that. So let's remove the device again. Oops, add 3W and then add it back. We can keep it actually on the Unix socket. It doesn't matter what the target is. The option is proxy underscore protocol. I think I set that to true. Oh no, actually apparently that only works in over TCP. Oh well. Okay, let me just reinstate my original ETH0 from the right one. There we go. Did it get an address automatically? That'd be pretty cool. It did. Okay, so I've got network again, which means I can do the TCP one again. Okay, so that's the one we had before. If I do that one back, and I do the while loop, and I connect, this works, nothing special, the text came through, but the source information would be gone. You have no idea who you're talking to. Now, removing this device again and adding it back, but this time with proxy protocol true, we'll see a difference in behavior down here. See, I'm connecting, and we see that first string that comes through before anything coming from the client. So here it says proxy, that's proxy protocol text header. What protocol came from? So it's TCP4 in this case, so IPv4 TCP. What the source address is, that's the IP address of my desktop machine. What the target address was, what the source port is, what the source port was. And with that information, you effectively have not lost anything. The problem is you need your software, your listening software inside the container or the VM to be able to understand that. There are proxy protocol modules for most software, whether it's HAProxy, Nginx, Apache, I believe Postfix, and a bunch of others all support that. So you need to go in their config and turn it on, effectively saying, hey, expect this string to come through. And then everything you'll see in your logs after that will show the real source IP address rather than just always showing the host IP address in this case. And that's really the main options as far as getting ingress traffic into LXD. As I said, like, it really depends on your use case. If you're at home on your home network with a few machines that are just running LXD, and you've got a home router that lets you route a subnet, go and do that. That's going to be the easiest way to just make everything accessible on your network. Every single machine on the network will just be able to do that. It's great. If that's not an option, or you're on a corporate network or something like that where you don't have access to the router, you can't go and modify things, then if you're willing to go through the initial hassle of modifying your system config, then set up a bridge that will get you the best experience. If that's not an option, then consider using Macvlan, but knowing that the host won't be able to connect to the guest. Another thing to keep in mind for both Bridge and Macvlan is they will not work on Wi-Fi. They can only work on wired networking, on wired network, because they use different MAC addresses for each guest, and Wi-Fi authenticates based on the MAC address. So you can't do that on Wi-Fi. And then if those don't work for you, or if you're in the cloud or in another environment where you can't get more addresses or you can't add more routes, then the proxy device is a pretty good tool because it lets you either do simple NAT on a per port basis, or it lets you do more complex proxy across different protocol, including then setting the proxy protocol header so you can figure out who you're talking to. It allows for very weird and interesting things, like you can technically proxy between DCP and UDP, or between DCP and a Unix socket, as I showed, which can come with like that kind of open some opportunities that you normally wouldn't really get. The proxy device is also being used to proxy more slightly weirder content, like X11 or Pulse Audio traffic for running Steam or the graphical application side of containers. So if you look at some of those videos, you'll see the proxy device being used for that, and that's another use for it. All right, well, I think that's it for going through all the different options to get traffic into LXD. Hopefully this was a useful way to picture all of them and see what works best for you. If you've got any questions around that, you can always leave them down in the comment section below or on our community forum. It's going to be linked in the description. Thanks for watching. See you in the next one.